Okay, let's unpack this. If you've ever used a big LLM and felt it just can't quite, you know, juggle everything at once, like be accurate, but also be concise and also use the perfect format, it's because the training signal literally collapses. So today we're diving into multi-reward reinforcement learning. It's this super complex process that tries to get these models to balance all our different preferences.
And our mission for this dive is to look at a potential fix for that very collapse. We're analyzing a new method from NVIDIA researchers. It's called Group Reward-Decoupled Normalization Policy Optimization, or GDPO for short. The goal is to see why it seems to solve these huge stability issues we see in the current standard, which is GRPO.
Right. So what does this actually mean for you, the person using the model? We're talking about the difference between an AI that just gets it, that follows your instructions, and one that gets confused because its training signals are all jumbled up. Let's start with that standard, GRPO. Why is it failing?
The failure really boils down to one uh, subtle but really devastating mathematical choice. GRPO takes all the different rewards, one for being correct, one for being short, and it sums them all together before it does any normalization. And that normalization step is what creates the advantage value. It's the critical signal the model uses to learn.
Okay, so that's where it gets interesting. By summing first, it's just throwing away all the nuance. It's kind of like, imagine you have 6 different shades of paint, maybe 3 greens and 3 blues, and you just pour them all into one bucket before you even try to figure out what the individual colors were.
Exactly. That's a perfect analogy. The paper actually quantifies this collapse. In a simple scenario, just 2 rewards and 2 rollouts, GRPO maps 6 totally distinct reward combinations into only 2 unique advantage groups.
Wow.
Yeah. You lose almost all of your expressive power. Things that should be very different learning signals just get mashed together into the same signal.
That loss of detail sounds, well, disastrous for training. So what did NVIDIA propose? What's the fix here?
They call it decoupled normalization. And the core idea is really just reversing the order of operations. Instead of summing first, GDPO does group-wise normalization for each individual reward separately. So, using your analogy, you measure the paints first, and only then do you combine the results.
Ah, I see. So the impact is immediate. You're just preserving the signal from the start. And if we quantify that, in that same example where the old GRPO method only kept 2 distinct groups.
GDPO retains 3, and this effect scales up. The more rewards or rollouts you add, the more information GDPO preserves compared to GRPO. It's not even close.
And that stability, I assume, leads to better performance.
It translates directly. We see really dramatic results in complex tasks, like tool calling. When they trained the Qwen 2.5 model, GDPO achieved about 2.7% higher overall accuracy.
Which is significant.
It is. And it also got over a 4% improvement in using the correct format. It just learns to do both things better at the same time.
And what about something like math? The instability of GRPO must really show there.
Oh, it's crystal clear in the data. With GRPO, the training on math problems actually started to destabilize after about 400 steps. The correctness score literally started to go down. It was unlearning. Meanwhile, GDPO just kept improving smoothly on correctness while also getting better at controlling the length of the answer.
That brings up a really good point about strategy then. It's not just about the math, it's about priorities. Sometimes one goal, like correctness, is way harder than another, like being concise. Just tweaking weights isn't enough.
Right. A much better strategy, which this enables, is conditioning the easier reward on the harder one. So you only get rewarded for being short if you are first correct. It makes the model focus on what actually matters most.
So to sum it up, GDPO with this decoupled normalization is just a fundamentally more stable and accurate way to train LLMs for these complex competing preferences. We're seeing it work across tool calling, math, coding.
Exactly. It fixes a core flaw in how we estimate the learning signals in any multi-reward setup. It's a much better foundation for building these models.
Okay, so here's a final thought to chew on. If getting high-quality, correct answers is really hard, and getting short, concise answers is pretty easy, what kind of weird, unintended behaviors are we baking into our AIs right now? By using these older methods that literally compress and lose the distinction between those important signals, something to think about.